Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2021 Mathematical Methods Exam 2 the extended response questions. So yeah, let's get ready. Okay, question 1. A rectangular sheet of cardboard has a width of h. Its length is twice its width, okay, which is shown over here. Square side length x centimeters, where x is greater than 0, so okay. So these are x here. Okay. And of course, x must be greater than 0. How can length be less than 0? I cut from each of the corners as shown in the diagram. The sides of the sheets of cardboard are then folded up to make a rectangular box with an open top, as shown in the diagram below. Assume that the thickness of the cardboard is negligible, okay, and that the volume of the box is greater than 0. A box is to be made from a sheet of cardboard. A box is to be made from a sheet of cardboard with h equals 25 centimeters. Show that the volume of the box in cubic centimeters is given by this. Okay, well, I know for a fact, okay, that this over here would be x. And, okay, this length over here would be 2h minus 2x. And this length over here would be h minus 2x. Okay. So it means that this length over here is h minus 2x, and this over here is 2h minus 2x. So the volume, the V box, is actually equal to, so let me write V of x, so V of x, so the volume of the box is equal to x times 2h minus 2x, h minus 2x, and we know that this is, if we take that 2x out, so it'll be h minus x, h minus 2x, and we know h is 25 centimeters, so it means that 2x, 25 minus x, 25 minus 2x, yeah, that's it. So, and we can write V box of x. Done. V box is 25. Okay, looks the same. Perfect. State the domain of V box. Well, we know that the V box is greater than 0. So, let me just draw a nice diagram over here. So, I know that there's going to be an intercept at 0. So, 0 at 25 and at 25 over 2, so over here. And is it a positive? Yep, so it's a positive. So we'll go like this. And we know that the V box is greater than 0, so we can exclude these value over here and this value over here. And yep, so we know that's 25 over 2 here, and this is 0, and that's 25. Okay, well, we know that, okay, so your domain would be only this over here, because it can only be over here, because it can only be restricted. Your x values cannot be infinite. It means, like, this one goes to infinity. So, our x values could only be limited, because the length can be only limited for this here. So, your domain should be, so dom of V box is actually equal to 0 not included, because remember, velocity is greater not equal to 0, and also 25 over 2 not included. Is that right? Looks right. Okay. Find the derivative of V box with the respect of x. So we want to find dv dx. Just let's use our calculator. So let's actually define the function. So we can say that V of x is defined as 2x times 25 minus x, 25 minus 2x. Okay, we got that. So, and we want to find the derivative. So, the derivative is 12x squared. So, okay, let's write that. So, 12x squared minus 300x plus 1250. That's it. Calculate the maximum possible volume of the box and for which value of x this occurs. Okay, so 3 marks, we need to show some working out. So we want that dv dx to equal 0. So it means that 3x squared minus 300, oh sorry, what am I doing? Okay, so we want that 12x squared minus 300x plus 150 equals 0. Now, just to show extra working out, let's go on our calculator and just go on like, I don't know, like algebra, factor this, comma x. Okay, no, don't do that. Just let's say, yeah, something like this. So this is factorized anyway. So let's say we factorize it. And it gives us this. So 6x plus, oops, what happened there? Plus 25 root 3 minus 3 multiplied by 6x minus 25 root 3 plus 3 all on 3 must equal 0. Meaning that your values, so your values over here would be these two possible values. So your x values would be, I'm just going to just do this easy, solve this equation equals 0 comma x, which gives us negative 25 root 3 minus 3 over 6, and x is equal to 25 root 3 plus 3 over 6. Okay, now we have that. So which one does the maximum occur? Well, it occurs at the, so we have 2 over here and here. This is your minimum value. Your minimum value is between 25 over 2 to 25, whereas your actual, your maximum occurs from 0 to 25 over 2. So we know that max occurs at 0 less than, so x is less than 25 over 2. Therefore, your x value is equal to negative 25 root 3 minus 3 all over 6. Now I'm going to make this smaller. At least now we know our x value. Okay, just make this smaller like this and put it over here. Now what we want to do is we want to sub that into our v of x. So that means that v of x, v of, let me just say v of negative 25 root 3 minus 3 all over 6 is, so v of this value over here, we want this value, which gives us, okay, this ugly value. So 15625 root 3 all over 9. All right, calculate the maximum possible volume. So this is units cubed. That's it. Is that right? Yeah, it looks right. Calculate the maximum possible of the box for which value of x occurs. Okay, waste minimization is a goal when making cardboard boxes. Percentage wasted is based on the area of the sheet of cardboard that is cut out before the box is made. Wait, percentage wasted is based on the area of the sheets of cardboard that is cut out. Okay, find the percentage of sheet of cardboard that is wasted when, okay. So, okay, the only thing that we cut in, like what we cut out is these over here. These boxes of, these boxes over here. These squares. These little squares here. So, we can say that there's how many? So, because we want area, because that's the actual, the inside of it. So we want, so that'll be x times x, so that'll be x squared, and there's 4, so 4x squared. So we can say 4x squared we have, and we know x is 5, so 5 squared is 25. So we have 100. And what is the actual volume of the whole box? Yeah, is that right? So we should, waste minimization is a goal when making cardboard boxes. Percentage waste is based on the area of the sheets of cardboard that is cut out before the make. Yeah, so we want the actual now area of the whole cardboard without being cut. So, and we know it's 2h and h, so plus 2h squared. Plus 2h squared, is that right? Yeah, so plus 2h squared. So that'll be okay. So this one is the cutout. Let's say this is your full, which is 2h squared. 2h. So 2h times h, yeah, 2h squared. So 2h squared, and we know h in this value is 25. So 25 squared. Okay, so doing this in a calculator, what is 2 times 25 all squared? It's 1,000 to 1,2. Okay, so it's 1,250. So your percentage is 100 all over 1,250 times 100. So I hope that's right. Is that the answer? So put this over here, multiply it by 100. 8%. So 8%, is that right? Percentage when making cardboard. Percentage waste is based on the area of the sheets of cardboard. Yep, that is cut out before the box is made. Okay, before the box is made. I hope that's right. Okay, now consider a box made from a rectangular sheet of cardboard where h is greater than 0. Okay, makes sense. And the box's length is still twice its width. Let v of box be the function that gives the volume of the box. State the domain of v of x in terms of h. Okay. So, okay. Now we don't know h. That's what they're saying. We don't know h now. So, the graph will look like this. So, it will be the same equation. So it would be, I'll just do a sketch over here. So it would be v of x, again, it will be, so it would be, yeah, these all multiply. So it would pretty much be this equation over here. It would be, yeah, this equation over here. So if you copy this equation over here, copy that, because that's when we haven't subbed in h. And let's actually sketch this. So your x value would be at 0, h, and h over 2. So let's say h over 2 is here. I mean, h must be greater than 0, of course. So, and h is here. So, and again, it is a positive graph, still the same graph. So, again, your domain, so because this is h over 2 and that's 0, wouldn't it just be still at like this over here? 0 to h over 2, not included. So, dom of v box, 0 to h over 2. Okay, find the maximum volume for find the maximum volume for any such rectangular v box in terms of h. Okay, so, well, we know that now, so we know that v box of x is equal to 2x, h minus x, h minus 2x, and let's find the derivative. So I'm going to just say v dash box of x is what? So shift minus, okay, and we want just 2x times h minus x, so h minus x times h minus 2x. Is that right? Yep. Enter, we get this expression over here, 12x squared minus 12hx plus 2h squared. Find the maximum volume. So, and we want to let this equal 0. So 12x squared minus 12hx plus 2h squared equals 0. Solve. So solving that, so if we go solve, answer comma equals 0, comma x, ans equals 0, comma x. And we get this expression over here. So we get h, these two, x must be h root 3 plus 3 all over 6, and x is equal to negative h root 3 minus 3 all over 6. So, okay. So, which one would be the smaller value here? So, I'm not, because we want the smallest value because we know it's between h over 2 and 0. So, the one, I think, would this be the smallest one? Let's just double check. Let's say the h is equal to 1. In this case, let's say h is equal to 1. We get 0.2 blah, blah, blah. Let's say in this case, we get, for this one, we get, okay, so the big, okay, so still this is the biggest one. So yeah, this would be the smallest, so the smallest one would actually mean for max is that. So just bring this. Let's just say max occurs at 0 h over 2. Therefore, x is equal to negative h root 3 minus 3 all over 6. And that's v, and we sub it in back, so negative h root 3 minus 3 all over 6. That's equal to, so we're saying v of, oh, okay, we can't actually say because it's a different v. So I'm going to take this, bring it over here, given that this value we want. It gives us this over here. So root 3 h cubed over 9. That's your answer. Is that right? Okay, that's your answer for that one. Okay, now consider making a box from square sheets of cardboard with side lengths h. State the maximum volume of the box. Wait, show that the maximum volume of the box occurs when x is equal to h over 2. Okay. Has side lengths of h. So now, let's just look at it like this. So now if I draw a sketch over here, so now it's a box. Let's say this is a box. So it would, and we're still cutting x's over here, but same distance. And let's say the side length, we know that the side length is h, so this will be h minus 2x, and this also will be h minus 2x. And these will be x's, by the way. So if we're going to put it all together, your volume of box of x is x times h minus 2x, h minus 2x. Yep, so which is just x h minus 2x squared. Okay, so if I'm drawing this graph, actually, let's just have a sketch of this graph. So we have 0, so let me just draw it, 0, and so h minus 2x equals 0, so h equals 2x, so h over 2. So h over 2 is, let's say here, it is reflected, oh yeah, so it's reflected and it goes like that. That's what we know. So what do we know about this more? So h is squared. Is that it? Yeah, looks right. Okay, so it's like this. The graph is like this, yeah? And so your maximum occurs over here. So it's between, yeah, your maximum occurs there. So we can say v dash of box of x is what? So if you just go derivative of x times h minus 2, oh, what's that? H minus 2x squared, actually, it's just squared, yeah. And we get this function over here. And we can write that over here, so 2x minus h, 6x minus h. So, and we let that equal 0, so the box of x must equal 0, meaning that 2x minus h equals 0, so equals h over 2, and we also have 6x minus h equals 0, where x is equal to h over 6. But remember, from here, if we look at this graph, we know that this point over here is what? H over 2. But that's where the minimum actually occurs. Minimum. So your maximum only occurs at H over 6. So we can say that max occurs at from 0, or like x. So we would actually say x is an element from 0 to H over 2. So x must equal H over 6. Done. So we've shown that, yeah. Question 2. 4 rectangles of equal width are drawn and used to approximate the area under the parabola y equals x squared from the area x equals 0 to 1. The heights of the rectangles are the values of the graph of y equals x squared at the right endpoint of each rectangle as shown. Okay, state the width of each of the rectangle. Okay, so if we halve this, that's half a quarter. So, and that should be 3/4. So this would be a quarter. Your width is a quarter. Find the total area of the 4 rectangles. Easy. So we want to say, so what's the width? It's a quarter. Well, actually, let me just say area. Area of rectangles is equal to a quarter, your width, multiplied by f of a quarter plus f, is that, well, let's say, yeah, let's say, let y equal f of x, something like that, yeah. So it'll be f of half plus f of 3/4 plus f of 1. So your area is, if I use my calculator, so let me first define the function. So control N this, all this rubbish, and say, add calculator and say, okay, f of x, define it as x squared. So x squared, so we want a quarter. Okay, yuck. A quarter f 0.25, I cannot be bothered running a quarter, plus f 0.5 plus f 0.75 plus f is 1. That'll be 15 over 32. 15 over 32 units squared. Find the area between the graph of y equal and the axis and the line equals 1. So yeah, just find the area. So the area is the integral from 0 to 1 of x squared dx. Okay, we need to show some working out. So it'll be x 3 over 3, 1 is 0, which is 1 over 3 minus 0, which is 1 over 3 units squared. Okay. The graph of f is shown below. Approximate from -2 to 2. So this is f. So -2. So from here to 2. Using four rectangles of equal width and the right endpoint of each rectangle. So we want from, okay, right endpoint. So we want this point over here to here. So we want this, because it's at the right, touches to the right. We want it to touch here too. We want to touch here too. So it's still at the right of the rectangle. And right to this rectangle too. Okay. Is this symmetrical? Nope. No, it doesn't look. It looks symmetrical. So I was going to, yeah. So let's do this. So it would be your area. So f2 to -2 of f of x is dx is equal to what? Well, what is the width? The width is 1. So we'll just put 1 here. And let's say you start off from -1 plus 0 plus 1 plus f on 2. So that will be, what's f of -1? So f of -1 is 6 plus 2 plus -4, just -4 actually. So just -4 and -6. So these cancel out. 2 minus 4, -2. So yeah, units squared. That is your answer. Part of the graph of y equals x squared and y equals x are shown. Find the shade area of the shade region. We'll just, yeah, just do this on CAS because it's only 1 mark anyway. So what we want to do is, because we've already defined, let's say f of x is x squared, let's say g of x is root x. And so what we want to find is the integral from 0. Oh, well, we need to find the intersection point. So what I'm going to do is I'm going to solve f of x equals g of x, comma x. Oops, what did I do here? Comma. Oh, what did I do here? Wait, comma x. Yep, so we get this. So it means that from 0 to 1 of the upper function, which is in this thing, g of x, minus f of x dx, which gives us 1/3. That's your area. So area 1/3 units squared. Okay, oops. Okay, the graph of y equals x squared is transformed to the graph of y equals ax squared, where a is b. So there's a dilation by a factor of some value between these parallel to the y-axis. Find the values of a. Values, okay, there's a law of such that the area defined by the regions bounded by the graph of y equals x squared and root x, and the lines x equals 0, yep, and x equals a, okay, is equal to 1/3. 1/3, okay. So, isn't it it's 4 marks. Okay, 4 marks. Wow. So there must be some trick into it. It's not that basic. I'm just trying to think. Wow, there has to be some hard stuff. There has to be some like extra information, like extra answers if they're giving us 4 marks. The graph is transformed. Okay. Define the values of a such that the area defined by the regions bound by this, and this is that. So, okay, let's just look at it like this. Okay, let's think of the area. So let's just say area. Basic area is what? We're saying from 0 to a. 0 to a of, because root x is always the top, so it will be root x minus ax squared dx equals 1/3. Is that right? So yeah, 1/3 equals, so a must equal, let's try this. So, okay, so if we say solve this from 0 to a, oops, of root x minus a times x squared dx equals 1/3, comma a, and we get 2 values of a, 0. So 2 decimal places, so 0.77, and a equals 1. Is that how basic it is? No, there's 4 marks for that. Nope, it doesn't look right. There has to be something else. 4 marks, wow, it's a lot. Okay. Wait, let's just graph these functions over here. Let's say that f of x is this. Let's say that the first graph is root x, and the other graph is ax squared. Oop, yeah, something like that. And we know that ax squared, oh, what did I do here? Yeah, ax squared, and we know that what's this? Oh, we only want a. Yeah, so our a value. And we only want it to be from positive because we know that a must be from 0 to 2 included. So 0, so put 0 here. Okay, so it can only be this. So what's happening? What did I do here? Okay, wait. Okay, x times x squared. Why is this capitals anyway? Times x squared. Okay, let's keep it. Okay, so it looks like this right now. And if I zoom it in, okay, and that's your area. So that's actually your first, and that equals 1/3. This one over here equals 1/3. And we know that another area occurs at 0.7, something like that. So if we a little bit, like let's say, if we decrease it, we can see it's just increasing the thing. And we know that Okay, so a equals 1, that is 1/3. And then we get a little bit bigger. Wouldn't the area just increase at that? Wait. Root x, no x squared. And is that, x equals a, between x equals 0 and x equals a. So if I go on relation and say x equals a, something that blocks that boundary. Okay, and we know, okay. So when it's at 1, okay, perfect. So when it's at 1, that is 1/3. That's 1/3. And we know at 0 point something, so 0.77. Also, this area here is 1/3. That's close to, like, let's say that was 1, that's 1/3. Okay, we can see. Okay, so imagine this, actually. So imagine that's 1/3. Right now, let's say that's 1/3, because 0.77, that's 1/3. And if we go up, let's say, imagine that was 1, and that's 1/3. But what can we see? What's happening to the red graph? It's just becoming smaller, and our value of a is getting bigger. So let's say if we went up more. Okay, if this is smaller, and this is some value, it should still equal some value of a, like if this is small plus something like this extra, and it should something equal 1/3. So there is an extra solution. Is there anything else? So wait. And nah. So then it becomes much bigger. So yeah, there should be an extra solution down there. So what we can do is we can actually find that point of intersection. Let's say find that point of intersection. And then, okay, so what's the point of intersection? It is x squared equals ax squared. Wait, what am I doing? Okay, wait. ax squared equals root x. And I'm gonna just solve for x, actually. Just let me solve for x. So solve. I don't want to make any mistakes. So x squared. Okay, nah, it's useless to do that, because then we have, okay. So I'm just going to do it by hand anyway. If I square both sides, so a squared, x4, x, it means that a squared, x4 minus x equals 0. Take an x out, a squared, x3 minus 1 equals 0. And that's x equals 0, makes sense, but the other one is a squared, x3 equals 1. X is equal, so x3 is equal to 1 over a squared. So x is equal to 1 over 3 cubed of a squared. So that's your value of that intersection. So what can we say? Well, we can say that another part of an area, so is from, if we look at the graph, 0 to that point. So we can say that 0 to 1 over 3 root a squared of, okay, the root x minus x squared dx plus another, so from 1 over 3 root a squared to the value of a. And now the big one is the ax squared minus root x dx, and that all should equal to a half. That should all equal to a half. No, 1/3. What am I doing? 1/3. So I'm putting this on the graph, and I should find an extra value of a. Okay. That's right. So we can say that solve 1/3 equals, so from 0 to 1 over the cube root of a squared. Okay, I need to make sure to do something here. I need to delete this graph because it's like the a is already defined now. So what I'm going to need to do is I'm going to delete this. So I controlled N, so okay, let me just redo it again. So 1/3 equals the 0 to 1 cube root of a squared root x minus a times x squared dx plus, oops, not that one, plus this value over here, copy that, paste it over here, a of now a times x squared minus root x dx. And we get this ugly function. So if we solve your answer, comma, a, we get a equals 1, which we already have, and this value, okay, a new value, a equals 1.13. So your values of a is 1.3, a equals 0.7, a equals 1. Those are your 3 values. Okay. See, if you see a question that's 4 marks and it was that basic, you know something's wrong. They're trying to trick you. That's what they try to do. Oh. Question 3. Let q of x equal this. State the maximal domain and the range of q. Okay, I'm just going to do this by calculator because I'll be honest, I'm already tired from this exam. So, I'm going to define q of x as the natural log. It's the same as x log ex, but I use the natural log because it's quicker to write in the calculator, and I cannot really be bothered writing like log e blah blah blah. So I just use natural log ln of 1 minus x. Did I write everything right? Perfect. So we can just say domain of q of x, comma x is this. So we can say state the maximal domain. So domain dom of q is negative infinity to negative 1, non-inclusive. And your range of q is, if we graph this, q of x, and we get this, looks like negative infinity to, is it going forever? Yeah, it's going up. I thought it was like an asymptote. Yeah. Just let me zoom back a little bit. Let me double check. Yeah. No, it's still going up, up. If I go to maybe some pointer. Nope, not pointer. Let's go on like, not that. Select. So try select region. No, okay. Okay, let's say graph trace, actually, just graph trace. And let's say, okay, so this is 5.13, and let's say negative 400. Negative 400. 5.99. What about negative 1,000? Okay, so it's still going up. We can see that the values are going up. They're trying to, I don't think, trick you in this thing. Yeah, so it was saying that it's from, where was it? Just let me go back so it would zoom fit. Okay, oh, yeah, what did I do here? Let me zoom out. Let me just, this value over here, let's say negative 20. Oh, negative 20. Can also change in value input. I'm just going to make another graph because really, q of x. Okay, so we got this, so it's negative infinity to infinity, or reals. Find the equation of the tangent to the graph at q1 equals this. So y equals what? So if we go on here and say menu, calculus, tangent line, q of x, comma x, comma, which value? Negative 2. Done. Quick and easy. Negative x minus 2. Find the equation of the line that is perpendicular. Wait. Find the equation of the line that is perpendicular to the graph of q when x is negative 2. And passes through the point this. So it passes through this point. So wait. Find the equation of the line that is perpendicular to the graph of q when x is this. And passes through the point this. So, just okay. So we know that the gradient of this was what? Negative 1. So we can say that negative 1 over negative 1 is just 1. Knowing that, we can say, we know already this value. So y minus 0 equals 1, x minus 2, so plus 2. Therefore, your y equals x plus 2. Okay, p of x is this. Explain why p of x is not a one-to-one function. So for the condition to be a one-to-one function is if it meets the horizontal line test, it has to really fit the horizontal line test. For example, let's actually p of x. Let's define p of x. Let's define p of x as e negative 2x minus 2e negative x plus 1. Plus 1. And if we graph this, let me just graph it on here and just let me take this out and say p of x. Okay, so we get this. If we do a horizontal line test, it hits 2 points here and here. It hits, and then you go further and it hits, becomes a 1-to-1. But if it hits more than, when it hits 2 points, when the horizontal line intersects more than once, it is not a 1-to-1 function. So we can just say it's not a 1-to-1 function. It does not pass. It does not pass the horizontal line test. Line test. Yeah. It does not pass the horizontal test. And that's it. I don't think you can write, but it's only 1 mark. Find the gradient of the tangent to the graph of this, P of this. Okay, so again, go on here. Go menu. Calculus. Tangent line. P of x. Comma x. Comma a. And, oh. What? All of that. Right, find the gradient, okay. Find the gradient of the tangent. So we only need this value over here. This value. Okay. Because I was like, oh, I'm not going to write the whole thing. If it was find the function, but it's gradient. So it's just 2e a minus 1 e negative 2a as your m value. That's it. The diagram below shows part of the graph of P, yep, and the line y equals x plus 2. The line y equals x plus 2 and the tangent to the graph of P at x equals a, and we don't know what a is, intersect with an acute angle or theta between them. Find the values of a for which theta is equal to 60. Give your answers to 2 decimal places. What ugly question is this? So for line y equals x plus 2 and the tangent to the graph of P at x equals a intersects with an acute angle. So they intersect with an acute angle between them. Find the values of a for which theta is 60. So we want theta to 60. So let's say we pick a point. Let's say this point over here. Let's say that's our point, and let's draw a tangent. I feel like this is 60. I feel like that's a nice 60. Yeah, I feel like that's a nice 60 degrees. So okay. So I think that's, yeah, let's say this is your 60. Let's say that was 60 degrees. Let's just say that was 60 degrees. It means that to find that value, if I draw a nice, and I know that the gradient, because I know that the gradient of this is 1, it means that the angle here is 45 degrees. So that's 45. And that angle over there is 60. Wait, and that angle over there. Yeah, and the angle over there is 60, and that's 45. Yeah, so it means that if we add both of those up, so your gradient, wait, the line equal tangent could intersect with an angle between them and find the values for which theta is that. Okay, so okay, we just need the gradient. So because we know that the gradient m is equal to tan of addition of both of them plus 45, which your value of m is what? So go on a calculator and say, what a ugly question. What's this, man? So because it's in radians, it's like pi on 3, so it's pi on 3 over here. So pi over 3 plus 4 pi, so pi over 4. Pi on 4 equals this over here. So negative 3.732, blah, blah, blah. And because we know that P of X, so we know that P dash of X, and we want to let it equal to that so we can find the value of X, which is equal to the A. So A would equal to, all right, shift minus X, P of X. Wait, what did I do? Oh my God, did I delete them? Oh my God. 10. Okay, pi on 3, so pi on 3 plus pi on 4 is this, and what we want to do is say that X, P of X is this. So we want to solve answer equals this over here, comma, X, and that's going to be your A value. So, and that's, what is this, error? Why is there an error? Okay. So I said, okay, P of X, wait, just double checking. So P of X is this. Okay, that's your function. And, is that right? Yes. Plus 1. So, and we're saying we want to let it equal to 0. Yeah, why does it not let me? So find the derivative of P of X, yeah. And we want to shift, okay, X this function over here equal, oh, what am I doing? Wait. So we know that this, so we want to solve, so solve answer equals, equals this, comma X. And still, argument must be an expression. Wow, what do I mean by that? Wait, have I done anything wrong here? Have I done? We know it's, so, if we want to comment X. I'll be honest. It's such an ugly question, but, so, find the gradient. We have this. That's your gradient. And we let it equal to this. Am I done anything wrong here? Equal this. And we want to solve answer, comma, X. And I okay, now we get a value. Yo, what was all that answer? What's all that rubbish that came? Okay, so 2 decimal places, 0.67. So we want now, because this says values, and let's just double check if there's more. So what other tangents is there? So we do a tangent over here. Well, no, this is greater. Could be. Nah, it doesn't look that well. So what about over here? So over here. Maybe, could be. Maybe over here. Say here. Oh, sorry. This is such a long question. Okay, this looks nice. So if it was over here, this looks like a good theta. So if we said that this was 60, and, okay, wait, so if we, if we just draw if that was a straight line and this was a line straight, it means that we know that this value is 45 degrees, and the total is 60, so we just need to find this here, which is 60 minus 45. So m equals 10. 60 minus 45 degrees. Yep, so if we do that, m will equal, let's try that. So tan of pi on 3 minus pi on 4, which is this ugly function, so 0.2679, and if we say p dash of x equals that value over here, and what our value of a would be, so again, same thing, so derivative of x of p of x is this, and what we want to do is we want to solve this answer equals to this over here, comma x, and still, okay, so I know what's happening, I think I know, it's, if I just go back to my old answer, this one over here, okay, if I just go back to this over here, and just change this expression, take this out, and say it's, where is it? Say it's this one over here. Yep. Comma x, and that gives you, what's this? What have I done here? Wait, so that's 60 minus 45, yep, so, which gives us this value over here. Okay, so, and what we did is, we've let it equal and we got these two values. I have no idea, wait, 1.836 and 0.173. So there's two values. They're saying that there's two values that could equal that. Let's just double checking. Are they both right? I think they are. So if it's 0.7, which is over here, which makes sense, yeah. If this brings yes, that's your theta, which is around 60 degrees. I mean, it looks, well, the other one's 1.8 something, like here. Like that. And that's also true. So maybe, is that an acute angle? Okay, so, okay, I think it's both of them now. So it's that and that. 0.183. If 0.183 is that, the tangent is that. Which looks like theta would be around 60 degrees, too. Yeah. Okay, so 0.17 and a equals 1.84. So your values is negative 0.67, a equals 0.17, and also a equals 1.84. I'll be honest, I am not too sure about this question. It took me so long to answer it. I have no idea if that's right. Look, I don't know. Yeah, it's so ugly, but such a long question for such 3 marks. Yeah, I'm not too sure. So if it's wrong, guys, please comment down below so I can, look at the answers and maybe have, find the x-coordinate of the point of, find the x-coordinate of the point of intersection between the line equals yx squared and the graph of p, and hence find the area bounded by y equals x squared, the graph of p and the x-axis both correct. Okay, this does not look bad. So, point of intersection, so we want to say x plus 2 equals p of x, and we want to solve for x, which gives us x equals, so we're saying p of x equals x plus 2, and we want to solve answer, comma x, which gives us negative 0, blah, blah, blah. So to 3 decimal places, this is negative 0.750. So we found the x-coordinate, and hence find the area bounded. So area, I have no idea how these graphs look. So if it's this, and we're saying, wait, I have the graph over here, actually. So at x-axis is over here. So we want this area over here. So to do this area, what we can do is, because we have the point of intersection, which is over some value over here, let's say it's over here, we can say that the area is from negative 2 to this value, and the function is x plus 2, so x plus 2 dx plus plus negative 0.750 to 0 of p of x. Yeah, p of x. Dx equaled... Oh, such a draining exam. Like, this exam is so ugly. I just that question has already made me like tired. Okay, x plus 2 dx plus, so this value over here again, 0 p of x, comma x, so this, and we get 1.0, okay, to 3 decimal places, that's 1.038 units squared. Okay, move on to the next question. A teacher coaches their school table tennis. The teacher has a adjustable ball machine that they use to help the players practice. The speed measured in meters per second of the ball shot by the ball. The speed measured in meters per second of the ball shot by the ball machine is normally distributed with a variable W. The teacher sets the ball machine with a mean of this and a standard deviation of that. Determine that this. Okay, this is nice. This is actually a nice question to really arrest you. So, add calculator, and what we want to do is go and graph probability distributions, and we want to go to normal CDF. Our lower bound is 11, our upper bound is infinity. Our mean value is 10, and our standard deviation is 0.8. Alright, and that gives us 0. This to 3 decimal places, that's 0.106. Find the value of k in meters per second, which 80% of the balls are below. So, if we draw this and say that some value of k is here, and we know that 80% of the ball speeds are below this, and that's 0.8%. This whole area is 0.8%. We can just use on our calculator, go on probability distributions, inverse norm. Our area is 0.8. Our mean value is 10, and our standard deviation is still 0.8. That gives us 10.67. So to 1 decimal place, k equals 10.7. Yeah. The teacher adjusts the height of the settings for the ball machine. The machine now shoots the ball high above the table tennis. Unfortunately, with the new height setting, 8% of the balls do not land on the table. Let P be the random variable representing the sample portion of balls that do not land on the table in a random sample of 25. Find the mean and the standard deviation. So we know that the expected value, so your mean of a proportion, is just the probability, so 0.08. And your standard deviation, so your SD of P, this is the square root of P1 minus P, was supposed to be these, over N. So, which is 0.8, 0.2, N value is 25, so that's equal to, okay, so 0.8 times 0.2, 25, 2 over 25, 2 over 25, okay, so right, so find the mean value is that, the standard deviation is that. I hope that's the formula for standard deviation, if I remember, yeah. Standard deviation is a square, okay. Moving on to the next question. Use a binomial distribution to find this. So, we know that P is equal to x over n, and to get x, it's 0.1 times your n value, which here was 25. So, okay, so 25 times 0.1 is 5 over 2, which is 2.5. So our x value is 2.5, which is equal to 3, by the way. It's binomial. There's no decimal places in binomial. Yeah, which is close to 3. The closest is 3. So this can be written as the probability as x is greater than 0. X is greater than 3. which is, if we go on over here, menu, probability distributions, binomial PDF, so 25 is, I think, probability of success is still 0.8. Lower bound now is 4, because it's not equal to 3, so the next value is 4, and our upper bound is 25. What have I done here? Have I made a mistake here? Use the button number. Why is it equal to 1? Ah, okay. To 3 decimal places, yeah. So use the binomial to find that p is greater. Wait, so I've multiplied that by that, and we got use this that. I'm saying that probably x is greater than 3. Let's try it again. Have I done anything? Binomial CDF. The number of tries we have is 25 still. Probability of success of still not landing the ball is 0.8. 0.08. Ah. 0.8. Okay, 0. This. Okay, so that's 0.135. Okay. The teacher can also be adjust the spin settings of the ball machine, spin measured in revolutions per second. In a continuous random variable within the probability density function is find the maximum possible spin applied by the machine. So the most highest is 50. Because okay, so 50. It's that's the highest, the speed, because it's equal to 50, and that's the most highest. Yeah, it's the highest and it's equal to 50. So yeah, that's your answer to that. That was very easy. Find the medium spin. Median spin. Okay. It's 2 marks, so we want to find the median. So it would be half equals from 0 to value. Oh well. So 0 to a of f of x dx, and we want to find the value of a. So let's actually define it. So let's say f of x is equal to, if I go over here and go to this one over here, and let's write the function. So we're saying x over 500 from 0, from x less than 20, 50 minus x, 750, and it's from 20 is equal to x 50. Okay, so we've defined it, and now we just solve. Half equals from 0 to a f of x dx comma a, and that gives us 22.61. Yes, 22 point, to 1 decimal place is just 6. That's it. And find the standard deviation of the spin and revolutions this. So, so, wait. I just need to check the formula. I just want to make sure. If I go to the methods formula sheet, I just want to double check if that's, so the, okay. So, for the variance, so we know that the variance is this, is from 0 to 50 of the function x minus your mean value squared f of x dx, yes? What is our mean value? Well, our mean value, so your mean value can be calculated from 0 to 50 x times f of x dx, which is so you just go over here, and so from 0 to 50 x times f of x, and that's equal to 23.33. So 23.33, and so it means that your variance is from 0 to 50 x minus this value over here. So we want to take this value over here and we want to square it. Oh, okay, not that. So just bring this over here. And we want to square it and times f of x. Dx. Wait, so f minus, so we square it, f of x. Okay, perfect. And that gives us 105 blah blah blah. So 105 to 5. But we want the standard deviation, so the standard deviation is the square root of that. Okay, square root of answer is what did I do? What's this one, right? Is 10.3. That's your answer. Okay, this looks ugly. And yeah, so question 5. Okay, the teacher adjusts the spin settings so that the medium spin is so the teacher adjusts the spin settings so that the medium spin becomes 30 per second. This will transform the original probability density function f to a new probability density function g. Yep, so there is a is our dilation by a factor of some value a parallel to the y-axis, and the other one's b parallel to the x-axis. Find the values of a and b for which the new medium spin is 30 revolution, giving your answers this. Okay, so how would I do this? 2 marks. 2 marks! Looks hard. Let's think. So, let's just say, I don't know how the graph looks actually. Let's say it's like some ugly function. Like, let's say it's this. Let's say it was like that. And we found that, something like that, yeah. And we found out that the mean value, say the mean value is in the middle. So that's 0, that's 1. So 0.5 is here. Your mean value originally was what? It was 22.6. So originally it was, oh, sorry, what? It was, 22.6, and this would be 50. This would mean this was 50. Yeah, so this was 50. And what's happened is that we've increased the medium. So if this transforms the graph to, like, it kind of, because again, this area has to all be 1. So this all areas has to be 1. So how the graph will look like, if say this was 50 again, still 50. No, not 50. It will change the value anyway. That's 0. The graph will look like, and that's now 30. The graph will look like something like that. So it look the same, but there's a change in it. There's a change. And this is your value of 50. This value we don't know because it changes. It transforms some value. Okay. Well, we know that this would have increased. It makes sense. Some value, it would have increased by some factor. Like if we multiply by some factor. To find that factor, it's what? 30 divided by 22.6. Or 30 divided by 22.6. We're saying 30 divided by 22.6 is 1.327. Okay. Wait. Wouldn't this be your b value? Because b value is multiplied by x's because it's a dilation by a factor of b parallel to the x-axis. So it's been multiplied by x values. So if this is our ratio, isn't this just your b value? B is equal to that. 27. Isn't it that? To do decimal places, it'll be 3. Okay, wait. Okay, so if that's our b value now, it means that, imagine, so 1.33 times 30. Oh, wait, times 50, times 50. So it means this value over here is 66.5. So what is, because, okay, remember there has to be dilation by a factor of a because to compensate for that, like, that thing, because it's increased, the graph will not look like this. It would actually look shrinked. Like, it will look like same, but it would look like, I don't know, something like that. Because it's lengthed. And this, again, this area must equal 1. And that value of A would be... Wouldn't it be this reciprocal? 1 over the value of B here? Is it... Wait, because if that graph is that, it transforms to this. Yeah, wouldn't it be the reciprocal of the value of B? Because we're trying to compensate. Yeah. So wouldn't your A value equal 1 over B? Because remember that B is transforming it, like it's making the X values bigger, which we can see. But to make sure that the A value compensates, it's just 1 over B. Let's try that. So A equals 1 over B. 1 over... what's our value of B? Which was this value here. So A is 0. So A 0.75. I'm so unsure. Let me just double check it by using my calculator. So let's say that from shift, okay. Now we've transformed the graph of, okay, wait. Okay, so let's say we transform this graph. Like, you know how, so it's A times, and our A value is this, so this times our F of X over B, and our X value of B is what? It was this one over here. Over B, and we get this ugly, oh yuck, like this value here. Now, let's say we want to find the integral from 0 to 66.5. So it should all equal to 1. If this whole function is right, it should... Oh, can I not copy the whole thing? Okay, this whole thing. Copy that. dx. Under... What the hell? Okay, I think that's right. I just don't know if that's... Yeah, I don't know if this question... I'm not too sure, yeah. I think that's right, yeah. To compensate, we've just found a reciprocal of 1 over B. Okay, I hope that's right. Is this the last question? I'm so dead right now. Okay, yeah, it is. So, last question. Let's do this quick. Okay, part of the graph of F is this. Okay, so it's addition of 2 graphs. State the period. So the period is what's repeating. So I'm just going to do this over here. I'm going to pick this value and this value. Find the difference. That should give us our peak value. So pi minus negative 3 pi. 4 pi is your period. State the minimum value of F. Your minimum value of F is this one over here. Somewhere around here. So let's define the function. So control N this. Let's say f of x is sine x on 2 plus cos 2x. Okay, and what we're saying is we want to find the minimum. So to find the minimum, we'll go on. Really, it's only, okay. We'll go on calculus, minimum value of f of x, comma x, comma from, let's just give a value, 0 to 4 pi. 0 to 4 pi. And we'll control enter gives us this value over here. So we can sub that value in over here. And that gives us negative 1.72 blah blah blah. So your min value is negative 1.722. Find the smallest positive value of h for which h minus x equals f of x. So so first imagine, so h minus x equals 0, so h equals x. So there's a translation to the right, and the graph is reflected along the x-axis. So just imagine just imagine that this graph over here, let's just pick some values like, I don't know, so like this over here. Let's try to redraw this over here. So if it was reflected along the, so this would be, let's say this was pi over here. Because it would be like, it would go like this, so it would be like that, that would be skewed, so it would be here, that, 2 pi over here, that. So we just need to see, so imagine that was our graph, and we want to make sure it goes to this. So we would, the next value is over here anyway. Yeah, so we need to translate it to the right. How many h units? Yeah, just look at this. This is 3 pi and that's pi. So 3 pi minus pi is 2 pi. Your smallest h equals 2 pi. Yeah, that's actually not bad, that question. I liked it. All right, consider the set of functions of the form this, g over a, blah, 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 where a is a positive integer. State the value of a, such that g of a equals f of x. Okay, isn't it the same? What? F of just 2. That's, yeah. Find the antiderivative of this. So your antiderivative is of this function. Okay, what I'm gonna do is I cannot be bothered, so I'm gonna just redefine that and just put a here now, over here. So if we want to find the antiderivative of that, so we're saying from f of x dx, that gives us this. So it is cos 2a x minus a cos x over a. Oh, is that right? Is that right? No, impossible, because if this will become like negative cos, and that'll be sine. So it have to, one of them has to have sine. Why it's not? Wait, it's f of x. If I just define f of x, it's that. Okay, f of x is that, and we find the antiderivative of x. Is that right? Find the antiderivative of g of a in terms of, find an antiderivative of g of a in terms of a, and I've done that. Yeah. So, I think that's right. Should be right anyway. And if you say, okay, antiderivative of g of a of x dx is equal to that. I'll be honest, I'm really gonna do it again. So g of x, because I'm not too sure that's right. Okay, g of x is sine x over a plus cos a times x, which means that the antiderivative of g of x, comma x. Okay, look, I don't know. Okay, this is the real answer. I knew something was wrong with this question. Something was wrong with my cat. Okay, so it's sine ax all over a minus a cos x over a. That's it. Use the definite integral to show that the area bounded by g of a and the x-axis over the interval from 0 to 2a pi is equal to above and below the x-axis for all value. Is equal above and below the x-axis for all value. If it was equal and above, the actual all area would be 0. The overall area will have to be 0 because it's equal to above and below. So imagine the area is equal to above and area below, and yeah, the area should be 0 at the end of the day. So we're saying, okay, here's different to show that from. Okay, so we're saying that, so integral from 0 to 2a pi. We want to show 0 to a pi of the, we already know the integrals what here. So sine ax over a minus a cos, what am I, what am I doing? Of g of x, okay, of g a of x dx is equal to sine ax over a minus a cos x over a to a pi 0. So let's say we sub into to a pi first. So we're saying sine 2a pi is 2 pi a squared over a minus a cos 2a pi, which is just 2 pi. 2 pi. Minus, if we put 0 on a sign, so sine 0 is just 0. And so minus a cos, so 0 over a is 0. So cos 0, we know that cos 0 is 1. So a. Okay, so doing this, simplifying this is sine 2 pi a squared, 2 pi a squared. So, okay, cos 2 pi is just 1, so negative a plus a. So that cancels out. And we want to show that it equals 0, by the way. If it equals 0, really, I don't. 2 pi a squared. Because, okay, imagine this. The a squared is being squared. So it must think about it like this. Let's say if we had a equals negative 1, it always gets squared, so it's always positive. So we have all positive values of the a inside this a. So just imagine, let's just imagine that a graph of this, a sine, so that's 2 pi here, let's say, that's 4 pi. Let's say a equals 1. That'll be 2 pi, which is still 0. Sine will equal 0. 4 pi. If it was 2, a squared, or a negative 2, it'd still be 4 pi, so it still equals 0. So I think, yeah, the sine 2 pi a squared is just always equal to 0. So we can say that sine 2 pi a squared is equal to 0 for all a values or something. For all a values. Yeah. So if at 0, this should equal 0. Yeah, so that's it. Is that how you show it? So use different to show that the apple. Okay, yeah. I think that's it. That should maybe give you the mark. Okay, let's just put it over here to show that at least we've done some like working out or something. Last question. Okay, last 2 questions. So these are supposed to be the hard ones, by the way. Explain why the maximum value of g of a cannot be greater than 2 for all values of a, and why the minimum value of g of a cannot be less than negative 2 for all values of a. So here, our a value is 2, by the way. Our a value here is 2. So, and we can see it's, negative 2 is over here. And a equals 2 is over here. Okay, over here. And okay, so it equals here. It says it cannot be greater, but it can actually equal, yeah? Yeah, it cannot be greater than that. It cannot be greater than 2. Okay, what I'm going to do is I'm going to actually graph it. Okay, wait. Explain the maximum value cannot be greater than 2 for all values of x. Or why the minimum value cannot be less than 2. Okay. Isn't it just the addition of 2 functions? Like imagine, okay. So let's say f of x, okay. Okay, g of a of x is what? It's equal to sine x over a plus cos of a of x. The amplitude of this value over here is what? 1. Plus the amplitude of this is 1, so 2. Your maximum value will be 2. And what it really cannot be greater than 2 because imagine just like the a value just dilates. It changes the x values, but it just only changes the x values. It doesn't actually change the y values. So, yeah, but it pretty much, I don't know how to explain this, but yeah, it means that, okay, if, we know that, okay, sine of x over a is an element, so the range of it is from negative 1 to 1. And we're adding cos of a of x, and the range of this is still negative 1 to 1. So the addition of both of them is just GA of x, which is an element from -2 to 2. Yeah. Is that how I would say? GA of x is equal to -2 to 2. Yeah. So that's your maximum. And it cannot be greater than that. Yeah, because of addition of ordinates, like imagine addition of ordinates. If you add two things, the y values add. And we've done that. I don't know, just say addition of ordinates. Something like that. Should give you some. Find the greatest possible minimum value of g of a. Wait, find the greatest, so the highest possible minimum value of g of a. Greatest means the highest possible minimum value. So if you look at, let's say, g of a, this is our minimum value over here. So we want it to be the highest. So we want it to be like this. Which one? Like we want it to be, which values of a will give us that? So, but not value of, like what values of a would give us that? What minimum value is there that is greatest? So I'm just gonna graph this. Let's just graph it. G of x and a. So this is how this looks. And look, if you just move this around, this is 2, and it never even gets more than 2. Can you see how it never? Okay, so let's say it's -1. Okay, still -1. There's no, okay. So if a is equal to 1, your minimum value is this over here. What happens if you say increase it? Wait, let me just double check. Analyze minimum. So it's -4 this value. Increase it. It becomes, when you're increasing it, so not maximum. You're increasing it, you're getting this over here. -1.72 now. Let's see, increase it to 5. Your lowest minimum value is, what the hell is this? Find the greatest possible. So we want the greatest, so the highest. Wait, find the greatest, so the highest possible minimum value of g of a. So it's -1. This is not high. Here, it's just, here it's nonsense. I have no idea. Okay. So, okay. The highest possible minimum value occurs from -1 and 1, which is the same value anyway. It's the highest one, is it? Looks like it's the max, the greatest, so it has the greatest. Yeah. It has the greatest minimum value. Possible minimum value. Because the other ones are just going more and more down. Yeah. So the more we go up, like let's say it's such a confusing question, 20. Let's say 20. And we put this. Alright. Okay, now the minimum value is just getting harder. So yeah. So the most possible, the best one is just 1. That's the most easy. That's the most least, because if you increase it, your minimum value just gets great. Your minimum value just gets like. So, look, this is what I'm so confused. Find the greatest. It means that we want it to be positive. It's like we want it to be like a little bit up. So, this is the most upward one. The other ones just go down. They get more down. Like if you look at they get more down, which is not what we want. So, yeah, A should be, so, is that right? Let's say A equals 1. So A equals 1. And we say, we go to menu, calculus, minimum of g of x, comma x, comma, I don't know, from 0 to 2 pi. 2 pi. Which is this value, and if we sub that in to our function over here, negative root 2. So a value is your minimum value, your min value, is equal to negative root 2. Is that right? Look, I'll be honest, this question, I think that's what it means. Find the greatest, yeah, your greatest possible minimum value is this, negative root 2. Yeah, if it's wrong, I'm not surprised, because it's such a confusing question. Yeah. Look, guys, I'm so tired. This exam, I'll be honest, it was a bad exam, I'm not gonna lie. It's like, it starts off nice, but then it gets to the most ugliest questions. So yeah, hope you guys enjoyed this video and learned something from this. If you want more videos, please make sure to subscribe and like these videos and share with your friends. Yeah, I do private tutoring. If you guys want tutoring, just please email me down below. The email will be just right over here if you guys need, or it'll be in my description, and you can just email me, yeah, and we can have a discussion. I do online tutoring, by the way, yeah, just online. Hope you guys enjoyed this video. Yeah, have a good day.